This next example gives f of x as a piecewise defined function. A piecewise defined function is when you have multiple equations, and then over here on the side you have some conditions. And the conditions are there to tell you when to use each of those equations. So this equation of x squared should only be used when your x is less than or equal to 0. And this equation of 1 over x should only be used when x is greater than 0. We have 3 parts to work through. Find f of -6, f of -5, and f of 5. So part A, f of -6. This notation is telling me what the x coordinate is. This is telling me that x is equal to -6. So then I'm going to go over to my piecewise defined function, and I want to go to the conditions and decide which equation to use. Since x is -6, I want to use this one right here. -6 is less than or equal to 0. That is a true statement, and I'll use that equation to work it out. So I'm going to substitute that -6 into the equation for x squared to get the answer of 36. Part B, f of -5. So in my conditions, -5 is less than or equal to 0. So once again, I'm going to use that first equation to work this out. -5 squared would be 25. Part C, find f of 5. So this time my x is 5 and 5 is greater than 0, so I'm going to use the second equation this time to work out the solution. 1 over 5 is 1/5, and that would be the answer for part C. For this question, we want to give the rule that describes the piecewise defined function in this graph. So we have a picture here of a graph, and we want to find the rule or the equation that matches this particular graph. So I'm going to start by figuring out the conditions on each equation. So because I have 2 pieces of the graph, I'm going to have 2 equations. So it's going to be f of x equals an equation with some conditions, a second equation with some conditions. So we'll figure out the conditions part first. So by looking at this first line, I can see that it starts at an x value of -8 and it stops at an x value of looks like -1. So the conditions for that first equation are going to be that your x, I'm going to write it a little bit bigger here, your x is going to be in between -8 and -1. So since the line started at an x value of 8 and stopped at an x value of -1, we're going to use that line whenever x is in between -8 and -1. You'll notice that I also put brackets on, not brackets, I put the lines underneath the inequality symbol to indicate that the endpoints will also be used for this line. So I did that because this endpoint has a filled-in dot and this endpoint has a filled-in dot. So the endpoints will be included, and that's why we have these lines here. For the other line, We'll do this one in purple. For the other line, I can see that this line starts at -1, and because of the arrow, continues on to infinity. So the conditions will be that x needs to be greater than -1. I didn't put the line underneath the inequality symbol because the end of that line is with an open circle. So that's how we get the conditions. Now we want to find the actual equation that matches these conditions. So I'll start with the easier one. So this line here that I'm highlighting is a horizontal line. Sorry, it's not highlighting. So the line that I've highlighted is a horizontal line. The equation of a horizontal line is y equals some value. And for this example, all of the y values are the same, which is a y value of 4. So the equation of that line is just 4. The horizontal line, 4. The other line is a little bit harder to find, but it is a straight line, and we do have 2 points on that line. And so we're going to be able to calculate the slope and to find the y-intercept. So this point right here is the point -1, 3, and the other point is -8, 4. So I'll use the equation or the formula y2 minus y1 over x2 minus x1. I'll let one point be x1, y1, and the other point be x2, y2. That's going to give me y2, which is 3, minus y1, which is -4, over x2. x2 is -1, minus x1 being -8. That's 3 plus 4 over -1 plus 8. That's 7 over 7, which is 1. So we have the slope of the line being 1. And then I can use point slope form, y minus y1 equals m times x minus x1. I'm going to use the slope in either of the 2 points. I usually try to use points with smaller numbers because I can do the math in my head a little easier. So I have y minus y1, so that's the 3, equals the slope of 1 times x minus the x value is -1 for that point. That's y minus 3 equals x plus 1, and I would add 3 to both sides. That gives me the equation y equals x plus 4. So the equation is x plus 4. So this is going to give me the piecewise defined function for this graph. So our function is this right here. F of x will be x plus 4 when x is from -8 to -1, including -8 and -1. And f of x will be 4 whenever x is greater than -1. For this question, we have the graph. We want to use the graph of a basic function and a combination of transformations to sketch the function. So our function is g of x equals -x plus 2 squared minus 4. So we want to figure out what the basic function is first, and we have a clue right here. our clue is this squared. So our basic function is y equals x squared. And we know the graph of that is a parabola where the vertex is at 0, 0. And then we have a bunch of transformations that are occurring for this function. And these transformations are the negative, the +2, and the -4. Those are all the operations that you don't see in our base function x squared. So we have the negative, the +2, and the -4. And each one of these transformations will do something different to adjust the graph of the basic function. So I have a little flow chart over here. We're going to take a look at these different transformations. So we have a transformation of a shift, and a shift is when you are adding or subtracting. So if your operation is adding or subtracting onto your basic function, then you may have a shift in the graph. That adding or subtracting can be inside or outside the base function, and that makes a difference about whether your shift is going to go up or down, or left or right. So if our adding or subtracting is on the outside, we're either up or down. If you have a plus, it's up. If it's a minus, down. If your adding or subtracting is on the inside of your base, plus is to the left, minus is to the right. So that's one type of transformation. Another type of transformation is when our operation is multiplying by a -1. And that transformation is called a reflection. So if you multiply by a -1 on the outside, you have a vertical reflection. Everything above the x-axis gets mirrored below. If your negative is multiplied on the inside of your base function, you have a horizontal reflection, and everything that's on the left is mirrored to the right, and everything on the right is mirrored to the left. And then we have a third type of transformation, and the third type of transformation is called a stretch or compression. And a stretch or compression happens when you multiply by a number. You can multiply on the outside or multiply on the inside. If you multiply on the outside, you have a vertical, either stretch or compression. It's called a stretch when the number is bigger than 1. It's called a compression when it's in between 0 and 1. If your number is multiplied on the inside, you have a horizontal stretch or compression. If the number is greater than 1, it's a compression. And if it's in between 0 and 1, it's a stretch. So this is the information that we're going to use to decide what type of transformations are occurring for our example. So in our example, we have this negative being multiplied, which means that it is a reflection. And because that negative is on the outside of our base function, it is a vertical reflection. The +2, plus is adding or subtracting, meaning that this is a shift. The +2 is on the inside of the base, making it a horizontal shift. And because it's plus, we're going to shift to the left 2 units. The -4 is also adding or subtracting, making it a shift. And because that -4 is on the outside of our base function, it's a vertical shift. And because it's minus, it's down 4. So this information is going to help me draw the graph. I'm going to make these transformations on the basic function. So we're going to start with the basic function and do these transformations. It's important to know what order to do them in because you may get a different graph based on what order you do. And for the order we're going to follow is we're going to do our horizontal transformation first, then we'll do our reflection, and then we'll do our shift. It's basically following order of operations. We do what's inside the parenthesis, then we do multiplication, and then we do the subtraction. So our basic function starts off looking like this here. It's a parabola with a vertex at 0, 0. Then we're going to shift all of these points to the left 2. So all of the points move to the left 2, and then our whole parabola is shifted left 2. Let me change colors so that you guys can see the difference on each one of these. So shifting left 2 would give us a parabola like this. Then the next transformation is reflecting. Everything that's above the x-axis gets reflected below, mirrored below, and then finally we will shift down 4, moving our vertex down 4. And this is going to give me my final graph because it's the final transformation. So the graph in red represents all 3 transformations. That's f of x equals negative x plus 2 squared minus 4, and will be our final graph. For this question, we want to use the graph of the known basic function and a combination of horizontal and vertical shifts to sketch the function. Our function is h of x equals the square root of x plus 1 plus 4. I'm going to write that a little larger. The square root of x plus 1 plus 4. So first we want to figure out what that basic function is, and there's a clue in our equation. We have the square root, and that means that our basic function is y equals the square root of x. The graph of that basic function is half of a sideways parabola, the top half of a sideways parabola. I can also see that we have some transformations within our function. We have a plus 1 and a plus 4. And we want to think about what those transformations are. The plus 1 and plus 4 are both transformations. Because they're adding and subtracting, I know that those are shifts. The plus 1 is inside the radical, so that is a horizontal shift. And the plus 4 is outside of the radical, so that's a vertical shift. Now, horizontal could be either left or right. Because this is a plus 1, I know it's going to move to the left 1. A vertical shift is either up or down, and because this is a plus 4, I'm going to go up 4 with my graph. So now I'm ready to graph my function using these transformations. I would start off with my basic graph. My basic graph is that half of a sideways parabola. And then I'm going to do the horizontal shift first, and then the vertical shift. So my horizontal shift will move to the left 1 unit, and then my vertical shift will move up 4 units. I should have used a different color there. So okay, good, I did. So this is the graph. The purple graph is the graph of our basic function shifted to the left 1 unit and up 4 units. The graph to the right was created by using 1 horizontal shift and 1 vertical shift of the graph of the basic function y equals x squared. Write the function that describes the graph to the right. So what I want you guys to remember about the basic function y equals x squared, it's the graph of a parabola like we see on the right, but the vertex of that parabola occurs at 0, 0, the origin. So we can see that the vertex of this parabola is not at 0, 0. And by looking at that vertex, we can figure out where we've shifted this graph to. It's got 1 horizontal shift and 1 vertical shift. So if I can figure those out, I'll know what the equation is. So from the origin, it looks like I shifted down 5 and to the right 2. So if I want to write the equation of this function inside the squared, I want to shift right 2. That means I would subtract 2. That would give me a horizontal shift because it's on the inside. Minus moves to the right, and I want to move 2 units to the right. Then I want to shift down, so I'm going to subtract 5. I put the minus 5 outside of the base function to make it vertical, a minus to make it go down, and I wanted it to go down 5. So this would be the equation of the graph that we see pictured here. Thank you for checking out my videos. Have a great day.